It turns out that unlike resistors, there are many different types of capacitors. Now, all of them essentially operate in the same way, except there's one difference. There are polarized capacitors and there are unpolarized capacitors. It's very important that you place polarized capacitors in the correct orientation. The correct orientation has the positive sign on the symbol and no symbol on the bottom, although in one of the two symbols here, the bottom, the negative terminal is curved. If you ever see a capacitor symbol where the top is straight and the bottom is curved, that gives you an idea of the fact that this is a polarized capacitor. Sort of a more modern symbol shows simply a traditional capacitor symbol with a positive sign on the top terminal. There are really two main types of polarized capacitors. There are electrolytic capacitors. That's the one that I'm most comfortable with, most accustomed to. And then there are tantalum capacitors. It's just important to be aware of the fact that both of them are polarized, and so you have to put them in the correct orientation. For the electrolytic capacitors, you'll see that there's a stripe along one side, along one terminal. That stripe usually has some negative signs drawn in it, and that's the side that needs to be toward the more negative voltage. It turns out if you don't do that, then after a few seconds of having voltage applied in the wrong direction, a few could be 10 or 30 seconds, it turns out that eventually the terminal will sort of decay to the point where it will actually become a short circuit. And this will actually cause a great deal of current to begin to flow, and that can actually cause the material inside the capacitor to begin to melt and even boil. It can actually even cause the capacitor to pop or even explode. That's not something that you want to do, so always be sure to put the capacitor in the correct orientation. Now, non-polarized capacitors come in many, many types. There are many types of non-polarized capacitors, but by far the most common one is the ceramic capacitor. They all look very similar to each other. A ceramic capacitor has sort of this orangish brown color, and they're usually in a disc shape. Sometimes, in fact, they're just called a ceramic disc capacitor. And then we also have silver mica capacitors, and these are sort of higher end capacitors. They tend to be more precise than the ceramic disc. This one might be plus or minus 5%. This one might be plus or minus 1%. The silver mica capacitors come in a variety of different colors. They're maroon. I've seen them this sort of bluish color. I've seen them yellow. Just be aware of the fact that both of those are non-polarized capacitors. You can put them in either orientation. It doesn't matter. And the symbol doesn't have any sort of plus or minus or curve on it because they're, of course, the two sides are completely symmetric. So it doesn't really matter which one you use. You might say, why are the electrolytic capacitors, why are the polarized capacitors worth the extra effort if you have to put them in the correct orientation? And the answer is because for the same amount of money, an electrolytic or a polarized capacitor will almost always have a higher capacitance. So just be aware that if you're looking for something that's pretty big, on the order of 1 microfarad or 10 microfarads or even higher, you're almost always going to choose an electrolytic capacitor. Whereas for smaller capacitances, things in the nanofarad or even picofarad range, you're almost always going to choose a ceramic or a silver mica capacitor.